These ironworkers' cottages were built more than 200 years ago. Crude by modern standards, with 2 tiny bedrooms and a shared outside earth closet, these houses were quite comfortable for the time. The ground floor was made from stone flags, or sometimes clay tiles, laid directly over levelled and compacted earth. Carpets were virtually non-existent, and people made do with homemade rugs and matting. Stone flags and clay tiles were easy to clean and didn't suffer much if they got wet. They were, however, cold and had an uneven surface. These middle-class townhouses were built about the same time. Most of these had basements, again with stone flag or clay tile floors. Towards the end of the 19th century, the standard of working-class housing slowly improved as planning controls and building acts became more stringent. In addition, cheap imported softwood became readily available. And by the early 1900s, most new houses were being built with timber ground floors. Timber floors were warmer and drier than flagstones and a much better surface for carpets and linoleum. Timber floors consist of a series of timber joists covered with timber boards. The floor is not in direct contact with the ground and is often referred to as a raised timber or suspended floor. In a typical floor from about 1900, the joist ends were usually built into the solid external walls for support. To keep joist depth to a minimum and to preclude the need for long, expensive timbers, additional support was provided by intermediate walls called sleeper walls. These could be built from brick or stone and were sometimes honeycombed to help ventilation of the floor void. A strip of timber known as a wall plate provided a level surface and a good fixing for the joists. Sleeper walls were sometimes built straight off the ground or on shallow foundations. Ideally, the ground level below the floor should be higher than outside to prevent the risk of ponding and flooding. The joist ends were susceptible to penetrating damp because in most cases they were only protected by half the thickness of the wall. The lack of effective damp-proof courses meant that joist ends and wall plates were also susceptible to rising damp. The bare earth or rubble infill beneath the floor was often permanently damp, and to prevent conditions which could lead to rot, the floor was ventilated. Terracotta or cast iron vents allow air to flow beneath the floor in an attempt to keep the underfloor space dry. In many houses, there aren't enough vents to do this successfully. A typical terraced house might have 2 or 3 vents at the front, but only 1 at the back. Ventilation at the rear of the property was often restricted because the scullery, where the washing would be done, usually had a flagged solid floor. This meant that a large part of the floor void, usually along the party walls and under the stairs, was poorly ventilated. When surveying old houses, these areas require careful inspection. In some houses, clay pipes laid under the scullery floor provided a through flow of air and better ventilation. Even if there are enough vents, problems can still occur if vents become blocked or if garden or paving levels change. In some cases, the vents are so low that water from paths can actually run into the floor void. In most Victorian houses, the joists were covered with square-edged softwood floorboards. Over the years, as the timbers naturally dried, the boards would shrink and twist. This could damage floor coverings, and the unsightly gaps between the boards could make the room drafty. In some houses, solid floors weren't just confined to the scullery. In better quality housing, the hall floor was often a solid concrete slab laid directly on the floor and finished with decorative tiling. A tiled floor provided a very durable finish. It also signalled prosperity and good taste to all who walked over it. The raised timber floor was used in millions of late Victorian and Edwardian houses. Improved building standards in the years after the First World War did, however, lead to changes in the way that these floors were constructed. No longer were joists built into external walls. By keeping the joists clear of the wall, risks of penetrating damp were avoided. Risks of rising damp were reduced by the introduction of effective damp-proof courses. Additional protection was provided by forming a concrete slab over the bare earth. This helped to keep the underfloor space dry. Many of these houses had tongued and grooved rather than square-edged floorboards. The interlock in tongued and grooved boards reduces twisting and eliminates drafts. They are, however, not as easy to lift for maintenance purposes. In the 1960s, timber floors were still popular. This example may not be textbook construction, but it hasn't given rise to any problems in more than 40 years. There's no wall plate, which is unusual. The joists sit directly on a course of engineering bricks laid on a bitumen felt DPC. The sleeper walls, however, are honeycombed to help cross-ventilation. Ground level below the floor is quite a bit lower than the surrounding garden. After long periods of heavy rain, water finds its way into the void. The tide mark shows just how deep it can get. Timber ground floors are not very common in modern construction, but they are quite acceptable. Unlike their earlier counterparts, modern floors are insulated against heat loss and are normally finished with sheet materials such as chipboard or strand board. In addition, the building regulations are more rigorous in terms of underfloor ventilation. Insulating older floors is quite easy and certainly cost-effective. The floorboards on this 1920s house have been carefully removed, and an insulating quilt has been suspended between the joists. The glass fibre quilt is wrapped in a vapour-permeable polythene to make it easier and safer to handle. Glass fibre can be a skin irritant. When the quilt was complete, the boards were relaid. An extra board was required in each room because the boards were relaid with finer gaps to improve appearance and help reduce drafts. This particular floor was then sanded and varnished. An alternative is to use rigid foam or polystyrene boarding supported on battens. If possible, the edges of the floor should also be insulated to prevent the risk of cold bridging and condensation.